everyone, I am Afidah M. Camar from STEM 11.5. In this video, I am going to give examples in the following topics: solving rational equation, solving rational inequalities, inverse function, solving exponential equation, and solving exponential inequalities. For the first part of this video, we are going to solve rational equation. Here, we are going to solve for 4 over x plus 1 minus x over x plus 1 is equals to 2. The first step we are going to do is to find the least common denominator or LCD of the rational equation. Since the denominator is similar, the LCD is simply x plus 1. Next, we are going to multiply the LCD to the both sides of the equation. X plus 1 times 4 over x plus 1 minus x over x plus 1 is equals to 2 times x plus 1. Since it is multiplication, we can simply cancel x plus 1, and this x plus 1 here. Thus, we have 4 minus x is equals to 2x plus 2. We need to group similar terms. Thus, we need to transpose negative x and 2. Thus, 4 minus 2 is equals to 2x plus x. 4 minus 2 is equals to 2 equals 2x plus x is equals to 3x. So, in order to remove 3, we need to divide 3 on both sides of the equation. So, we have x is equals to 2 over 3. Therefore, the value of x in this rational equation is simply 2 over 3. To check if x is really equal to 2 over 3, we can substitute 2 over 3 to all the x values in the rational equation and check if the answer is equals to 2. So since the denominator is similar, we can simply write it as 4 minus x is over x plus 1 equals to 2. So 4 minus 2 over 3 over 2 over 3 plus 1 is equals to 2. Now, let us simplify the numerator and the denominator. So, 10 over 3 over 5 over 3 is equals to 2. Now we're going to divide 10 over 3 over 5 over 3 is equals to 2. In dividing a fraction, we need to multiply the numerator to the reciprocal of the denominator. Thus, we have 10 over 3 times 3 over 5 is equals to 2. 10 times 3, 30, over 3 times 5, 15, equals to 2. 30 divided by 15 is 2, is equals to 2. Thus, the value of x is correct. For the second part, we are going to solve for the inequality of 3x plus 1 over x plus 4 greater than or equal to 1. So the first step, we are going to make this a single fraction. To start doing that, we are going to make the other side of the inequality 0. To do that, we are going to transfer 1 on the other side. Thus, we have 3x plus 1 over x plus 4 minus 1 greater than or equal to 0. Next, let us determine the LCD, which is obviously x plus 4. Then, we will multiply the LCD to the rational expression and to the negative. Thus, we have x plus 4 times 3x plus 1 over x plus 4 minus 1 greater than or equal to 0. X plus 4 times 3x plus 1, x plus 4 times negative 1, negative x, negative 4 over x plus 4 greater than or equal to 0. So since they're similar, we can just cancel them out. We have 3x plus 1 minus x minus 4 over x plus 4 greater than or equal to 0. After that, we are going to combine similar terms. So we have 3x minus x plus 1 minus 4 over x plus 4 greater than or equal to 0. So we have 2x minus 3 over x plus 4 greater than or equal to 0. On this side of the inequality, this is now our single fraction, and on the other side is 0. Since it is now a single fraction, we are going to determine over what intervals the rational expression takes on positive or negative values. First, let us equate the value of numerator and denominator to x. So for the numerator, 2x minus 3 is equals to 0. So transpose 2x is equals to 3. And then divide both sides into 2. Thus, we have x is equals to 3 over 2. For the denominator, we have x plus 4 is equals to 0. So, transpose x is equals to negative 4. So, these two x values here, we are going to put this on our number line. In drawing number line, we are going to draw two empty circles since we have two x values, and then draw a line on the both sides of it with arrows, of course. So on the empty circle on the left side, we are going to put negative 4, and on the right side is 3 over 2. Please remember that the negative will always be on the left side. Now that we have our number line, we will determine if these x values are part of the solution. To do this, we will substitute this to the x on the original inequality. So we have 3 times negative 4 plus 1 over negative 4 plus 4 greater than or equals to 1. So the result will be negative 11 over 0. So since the denominator of a fraction should not be equal to 0, thus this is actually undefined. Thus, x equals to -4 is not part of the solution. So for x is equals to 3 over 2, we have 3 times 3 over 2 plus 1 over 3 over 2 plus 4 greater than or equal to 1. So the result will be 11 over 2 over 11 over 2 greater than or equals to 1. So 11 over 2 over 11 over 2 is obviously 1. Thus, 1 is greater than or equal to 1. Thus, x is equals to 3 over 2 is part of this solution. Back to the number line, we will going to shade 3 over 2 since it is part of the solution. In our number line, actually, we have 3 intervals here. First, from this to infinity, x is less than -4. And then from this to this, x is greater than -4 but less than 3 over 2. And then from this to the infinity, x is greater than 3 over 2. So since we already know our 3 intervals, we are going to make a sign table. So let us put our intervals on the top. So inside our intervals, we will get a test points. So we must get a number that is near the interval so that it will be easy for us to solve it. So now, using our test points, we will substitute it to the x on the numerator of a single fraction inequality. Note that we do not need the actual answer here. What we all need is the sign in the actual answer. This is why it is called the sign table. So for x is equals to -5, for example, it is negative. This goes the same with other test points. So for x is equals to -2, the answer is actually negative. And then for x is equals to 2, the answer is positive. The process is similar with the denominator of the single fraction inequality, which is x plus 4. So we will substitute the test points to the x of the denominator of the single fraction inequality. So for x is equals to -5, it is negative. For x is equals to -2, it is positive. For x is equals to 2, it is also positive. Now we have the single fraction inequality here. So for this, we will just multiply the result of the numerator and denominator. So negative times negative is equals to positive. Negative times positive is equals to negative. And positive times positive is equals to positive. So how do we determine the answer from this table? Well, since the inequality says that it should be greater than or equal to 0, then the interval must be composed of 0 and positive numbers. This means that the interval x is less than -4 and x is greater than 3 over 2 is part of the solution because they are all positive numbers. back to our number line. Again, the interval x is greater than 3 over 2 is part of the solution, and x is less than -4 is also part of the solution. So how do we write this? So for set notation, we have x is all real numbers, x is less than -4, or x is greater than or equal because it is part of the solution. Again, it is shaded, so we should have an equal sign. So x is greater than or equal to 3 over 2. So for interval notation, we will write this as open parenthesis -infinity to -4 close parenthesis union bracket, because it is part of the solution, so we will change the open parenthesis into bracket, 3 over 2 to infinity, and then close parenthesis. So this is now our answer. For the third part of this video, I'm going to find the inverse of g of x is equals to 3x minus 8. So first, let us write the function in the form of y is equals to f of x. So the first step, let us change g of x into y. So we have y is equals to 3x minus 8. Next step, we will going to interchange the variables y and x. So this become x is equals to 3y minus 8. Now let us solve for y in terms of x. To solve for y, let us transfer 8 on the left side. To find y, let us divide 3 on both sides of the equation. Thus, we have y is equals to x plus 8 over 3. Therefore, the inverse of x is equals to x plus 8 over 3. For the fourth part of this video, we are going to solve for the exponential equation 7 to the power of x is equals to 1 over 49. The first thing we should assure here is that the base should be similar on the both sides of the equation. But since the base here is not similar, then we need to set 1 over 49 into base 7. Recall that in the law of exponent, particularly for negative exponent, a to the power of negative x is equals to 1 over a to the power of x. 7 squared is equals to 49. Thus, 1 over 49 or 1 over 7 squared is equals to 7 to the power of negative 2. Thus, 7 to the power of x is equals to 7 to the power of negative 2. Now that we have the same base, we can equate the exponent now. So x is equals to negative 2. For the last part of this video, I am going to solve for the inequalities of 4 to the power of 3x plus 2 less than 64. Firstly, Like we did on solving exponential equation, we should assure that the base should be similar. Since the base is not similar here, thus, let us set 64 into base 4, according to the law of exponent. So, if you think of it, 4 times 4 times 4 is simply 64. Thus, our inequality now is 4 to the power of 3x plus 2 is less than 4 cube. Now that we have similar base, next, let us check the direction of the inequality. According to the properties of inequality, if the base is greater than 1, the direction will be retained. But if the base is less than 1, then the direction will be inverse. So our base is 4 and 4 is greater than 1. Thus, the direction of our inequality will be retained. Since we know that the direction of the inequality is retained and the base is similar, we can now equate the exponents. 3x plus 2 is less than 3. We are going to transpose 2 to the right side. So 3x is less than 3 minus 2. 3x is less than 1. Now let us divide 3 on both sides of the inequalities. X is less than 1 over 3. For interval notation, we have open parentheses, negative infinity to 1/3, close parentheses. For set notation, x is all set of real numbers less than 1 over 3.